Hi, we're starting with section 12 from our course today, and our prep skills for section 12 are to use order of operations, and I believe that's our only one. Let me double check that. Yes, using order of operations is our only one for this lesson. So we're going to review the steps for that, and I can't emphasize enough how much I do not like the acronym that a lot of people use called PEMDAS. When using this acronym PEMDAS, it makes it look like there's 1, 2, 3, 4, 5, 6 steps in the order of operations, but there's not. There's only 4. It's not parentheses, exponents, multiply, then divide, then add, subtract. The parentheses comes first, the exponents come second. Multiplication and division goes left to right at the same time. So if you run across a multiplication or a division, you go left to right and you do all of those. And then the 4th step is use addition and subtraction from left to right. Some people will use the acronym please excuse my dear, because it kind of sounds like it goes together like multiplication and division do, and Aunt Sally. So just a quick reminder of that we don't want to think of this as 6 steps. PEMDAS is not a good acronym to use. I would try to avoid that if you could. So now, if we go to this problem, let me write them off to the side. They don't give us enough room here. When we do this problem, there's an addition and there's a multiplication. Well, our rule says that we're supposed to do multiplication and division before we do add and subtract. So we're going to do this multiplication before we do any addition. So this is going to be 12 plus 12. And then all we have left is the addition, and so we add. So 12 plus 3 times 4 gives us 24 because we're going to do this 3 times 4 first before we do the adding to 12. On the next one, we have 4 times 3 squared equals 4 times 9. And that is because we're going to do the exponent, in this case, is going to come, this exponent is going to come before this multiplication. Remember, if there's nothing between the number and the parentheses, that just means a multiplication. So 4 times 9, because 3 squared is 9. And then 4 times 9 is 36. So 4 times 3 squared is 4 times 9 is 36. Again, we're going to do this portion first before we multiply by the 4. On the next one, we're going to do 81 divided by 12 minus 3. And in this case, even though this is a subtraction, we're going to do the subtraction first because it's a parentheses. So we're here with the parentheses. We're going to do that parentheses first. So we're going to do 81 divided by 9. And 81 divided by 9 is the only thing left, so that would get us 9. Now this next one has 3 operations. 52 minus 8 divided by 4 times 6. So as we look from left to right, we have a subtraction, we have a a division and a multiplication. Well, I can't do the subtraction yet because multiplication and division are a step above addition and subtraction. So I want to do this multiplication and division first, but I'm going to look from left to right. I'm not going to do this multiplication before the division. I'm going to do all the multiplication and division from left to right as I see it. So 8 divided by 4, 52 minus 2 times 6. Now I'm going to do this multiplication before I do the subtraction. So 52 minus 12. And 52 minus 12 is 40. So that's where we get 40 from that. On the next one, this division bar here acts as a as if there's a parentheses above and below. So we have to do whatever's on top and whatever's on the bottom before we divide. So 7 minus 9 would get us -2. 3 plus 5 would give us 8. And now we're ready to divide, and we could either say -1/4, just reduce the fraction, or we could say -0.25 if we want to take 1 divided by 4. That would get us 0.25. And of course it's a negative. So then our last one here, we've got two sets of parentheses for this one. We've got an innermost set and an outer set. And the rule with that is if you have a parentheses within a parentheses, since the rule is that you're going to do what's inside the parentheses using the order of operations, if we think of this as our first set of parentheses, then within that parentheses we're going to follow the order of operations. So we're going to do this innermost parentheses first also. So if you think of this, forget about the two, just think about this. Then within that, since we're doing the parentheses first, within that parentheses we do the parentheses because it's inside of that set of parentheses, and the first part of the order of operations is to do parentheses. I know that's a little bit confusing, but long story short, you want to do the inside set of parentheses first. So we're going to do, oh, and I can't forget the -4 that's on this problem. So we're going to do -2. We're going to do this inner set of parentheses, which is 4 squared. And we still have to complete this parentheses, because remember, it's parentheses, exponents, multiply, divide, add, subtract. So we're going to do this inside the parentheses. We're going to do this multiplication and division. So we haven't gotten to the exponent yet because we haven't gotten done with the parentheses yet. So inside here we have -8 squared minus 4. And now we finally got rid of that parentheses that was there on the outside, this one here. And now we can move on and do the exponent. So the exponent is squared. So -8 squared is 64, because remember that's -8 times -8. So a negative times negative is going to give us a positive. 64 minus 4, and then we get 60 from that. So now we're going to have the prep skills questions, and what I would recommend is that you pause it at this point and do the prep skills questions, and then turn the video back on and watch the answers. So you can do it, do 1, then check it, then do 2, then check it, and so on, or you can just do all 4 problems and then turn it on to see. So hopefully you've done these problems already and you paused it like I recommended. 3 to the 5th would be 3 times 3 times 3 times 3 times 3, or again, you can do this on your calculator and just push. Typically on most calculators it's 3 to the 5th power like this, or you might have 3 with a button that looks like this, like a little x to the y, or it might be an a to the b, 5. And 3 to the 5th should get you 243. If you're doing this problem on your calculator, make sure that you put a parentheses around the -2. So parentheses -2 to the power of 6 would get you 64. This would be 1/2 times 1/2 times 1/2 times 1/2. Or you can do 1/2 to the 4th power on your calculator. If you're going to do these on your calculator, the best thing to do is to put it in as a fraction so that you get back a fraction. On most calculators, you can either push 1 and then there'll be a button that looks like, it just depends, but it might look like an n over a, actually on most of the smaller or the cheaper TI calculators, it'll have a, it'll look like A, B over C, like this, and you push 1, that button, and then 2. You're just telling the calculator I'm doing a fraction. When you push that button, you're just indicating to the calculator I'm doing a fraction. On other calculators, you'll see something that'll look like this. It might have like little boxes like this, or it may have just little boxes like this. And then when you push that, it lets you fill in the boxes. So I would do 1/2, however you need to put it into your calculator. And once you get that 1/2, then do your power button, whether that's this up arrow or the X to the Y button or whatever it might be, and do that to the 4th power. If you do that, you should get 1 over 2 times 2 is 4 times 2 is 8. 1 over 16. Okay, and that's because it does 1 times 1 times 1 times 1, and 2 times 2 times 2 times 2, which is 1 over 16. Now this one's a little bit different. This negative is out in front, so this is just negative 5 squared. So the negative is just going to hang around on the outside, and this is actually negative 25. You notice this is different than the one that we did for B, because in B, whoops, that's not what I meant to do. I'll have to just leave it there. In B, we had a parentheses here around the negative 2. Here we don't. Here it has the negative out in front, so it's negative 5 squared. And so we do the 5 squared first, and then we put the negative on it. Here, this is negative 2 to the 6th, so that means negative 2 times 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 negative 2. It's negative 2 6 times. Here we only have one negative and then 5 twice. So if you wanted to think of it like that, it would be negative 5 times 5. You only have one negative and 2 5s. 2 factors of 5. Okay, for this next one, this would be 12 plus 10, because we're going to do the the division before the addition. And so that's going to give us 12 plus 10, which is 22. On this problem, we're going to do the multiplication before we do the subtraction. Negative 4 times negative 6 is 24. Then minus 7 would give us 17. Okay, and then on this next one, we're going to, again, follow this order of operations. Parentheses, exponents, multiply, divide, add, subtract. So our first step, we're going to look for any parentheses, which we don't have. Then we're going to look for any exponents, which in this case we don't have. So we're going to do this multiplication and division from left to right. Here's a multiplication. That'd be 28 minus negative 60. I'm going to go ahead and switch that now because we can switch that to plus 60. And then divide by 12. But we have a division here, so we want to make sure we do that division. Again, we're still on multiply and divide from left to right. So we're going to do this division before we add. So that would be 28 plus 5, because 60 divided by 12 is 5. And then 28 plus 5 would be 33. So the answer for C is 33. For this next one, following order of operations, we're going to do the parentheses first. So 20 plus 2 times 5 squared. Next, we're going to do any exponents, which we do have. We have a square. Let me put this one down here, kind of out of room. So that's 20 plus 2 times 5 squared would be 25. Then we're going to multiply before we add. So 20 plus 50, which is 70. So 3a is 70. This next one, we've got the cube is on the 3, but not on the negative. So this is negative 3 cubed, which would be 27 times 2 minus 42. And I wanted to do that exponent because that comes before multiply and divide. So we did the exponent of 3. Now we're going to multiply. Negative 27 times 2 is negative 47. And then negative 47 minus 42 would be negative 89. And so 3b is negative 89. Take this one over here. We've got 12 plus, I'm going to do the 20 times 30 first, or the 2 times 30 first, which is 60. We still have a divide 5 on the end. I'm going to do this division before I add. So 12 plus 60 divided by 5 is 12. And 12 plus 12 is 24. So 3c is 24. Okay, I'm going to scooch down here a little bit so I have some room. For 4a, I've got 8 minus 1 as an innermost parentheses times 3 squared. So as we said before, we want to do the innermost parentheses first. So I'm going to do 7. 8 minus 1 is 7 times 3 squared. Still working on the parentheses, so I'm going to do that next. So 7 times 3 is 21 squared. And 21 squared is 441. For B, we've got 2,000 on the outside. 1 plus 0.0, whoops, got that in the wrong spot. 0.05, and then that to the 12th power. So we're going to do what's on the parentheses first. And that gets us 1.05 to the 12th. And according to order of operations, I'm going to do the exponent before I do the multiplication. So 1.05 to the 12th power is get an approximation here. It's 1.7958. So I'll say 1.796. It doesn't say how to round it, so I'm just choosing on my own to round that to 3 decimal spots. So 1.796, and then we want to take that times 2,000. And I got approximately $3,591. And I'm going to say 0.71. I'm assuming, not assuming, but this is kind of modeling a interest rate problem with this interest rate, and the 12 kind of looks like an interest rate problem. So I'm going to take it to 2 decimal places like it's money. But there's nothing that said I had to do that. That was just my choice. So $3,591.71 or 3,591.71. All right, this problem here, we've got some room under here, so we'll do it. We're going to do the parentheses first, and then next we're going to do the exponent. But since those don't really affect each other, I'm going to do them at the same time. So 1.045 to the power of 2 is 1.092, and I'm rounding that, minus, we're going to work on the inside here, and I'm going to do this multiplication before I add. And I'm going to go ahead and do both multiplications. So I'm going to do 10,000 times 0.045 times 2. And I got 900 from that. That was just this bit. So I've got 10,000 minus 900. And now I want to do, again, the innermost parentheses. And then I'm going to multiply. But these don't affect each other, so I'm going to go ahead and do them all at once because this is my first step. This is my second step, but they don't affect each other. So the 10,000 minus 900 would give us 9,100. And then 10,000 times 1.092 is going to shift the decimal over 3 spots and give us 4 spots rather, 10920. And then we subtract the 9,100, and we have 1,820. So 4C is 1,820. And then last but not least, sorry, I kind of got all over the page here on this one. I'm going to go down here. We've got 7 minus 3 plus 4 squared. And then that's an inner parentheses. And then on the outside of that parentheses, we've got another square. So we're going to work on the inside first. And inside this parentheses, I'm going to do the parentheses first. So inside the parentheses, I'm still going to follow order of operations, which means I'm going to do parentheses first. So 7 minus 7 squared. Now that's not going to become 0 because I'm not going to do the subtraction first. I'm going to do the exponent first. That's what order of operations says. So I'm going to do 7 minus 7 squared is 49. Still have that square on the outside. I haven't done anything to it. All I did was do this 7 squared. And then 7 minus 49 is negative 42. And then we're ready to square. So negative 42, don't forget to put parentheses around it, negative 42. And we square that, we're going to get a positive number because it's a negative times a negative. And we're going to get 1,764. And so the answer for 4D is 1,764. And now we're going to pick up with the class and the group portions and of this lesson. So We will be back with that in just a second here.
In question 1, you're asked to think about what is a variable. And this is really a personal question for you to think about what your perceptions of that are, but a common answer is to say something like, it's the letter X. And what they'll tell you in the paragraph below is that that's not really true. A variable is a quantity that varies. In question 2, which of these makes more sense? The amount of time you spend studying depends on the grade you earn in a course, or the grade you earn in a course depends on the amount of time you spend studying. Well, hopefully you thought B. Studying more can help to improve your grade, so your grade depends somewhat on the amount of time you spend studying. And in 3, list other factors that are also likely to impact your grade in this course. Well, those could be lots of different things, such as attendance, participation, homework completion, and even attitude. Here we're looking at independent and dependent variables. In A, the age of a tree and the height of a tree. Which of those do you think is the independent versus the dependent variable? Well, the height of the tree could be influenced by its age, but a tree isn't going to be old just because it's tall. So in this case, the height depends on the age. So the height is the dependent variable, which makes age the independent variable. In B, the number of practice sessions and the quality of a musical performance. Well, the quality is more likely to be influenced by the number of practice sessions. So the quality would be the dependent variable and the number of practice sessions would be the independent variable. In C, your score on a placement test and the math courses you've taken previously. Well, you're probably going to score better on a placement test if you've previously had more math courses. So the score on the placement test would be the dependent variable and the math courses you've taken would be the independent variable. In D, your blood pressure and the amount of time you spend exercising each week. Well, exercise can help your blood pressure, so your blood pressure is the dependent variable and the amount of time you spend exercising is the independent variable. In E, the value of a share of Apple stock and what year it is. Well, the value of Apple stock is going to change as the years go by. The years aren't going to pass because of the value of Apple stock. So that makes the year the independent variable and the value of the Apple stock the dependent variable. In F, the number of songs a band sells on iTunes and the amount of money spent on marketing. Well, sales often changes in response to marketing expenditures. So the number of songs would be the dependent and the amount spent on marketing would be the independent. In G, the cost of a cab ride and the number of miles that you are driven. Well, the cost of the cab ride depends on how many miles you ride in that cab for. So the cost is the dependent variable and the number of miles is the independent variable. And in H, the number of customers that want to buy a certain product and the price of that product. If you have any familiarity with economic principles, you might realize that this one can be argued either way. It is true that lower prices can cause more customers to want to buy a product, making price the independent variable. Or having a lot of customers who want to buy a product can drive prices up, which would make the number of customers the independent variable. So this one could go either way. In question 1, you're just supposed to discuss with your group these 3 definitions and how they're different and how they're similar. So an expression is a combination of variables and constants with operators or grouping symbols. There's no equal sign in an expression. It's just variables and numbers with plus, minus, multiply, divide, square root, those types of things. An equation is 2 expressions with an equal sign between them. So all of these have equal signs. The expression could just be a number on one side. It could be a variable on one side, but it has to have an equal sign. A formula is an equation, but it's an equation that's equal to a variable that stands for some quantity that we're interested in. So we have area formulas, perimeter formulas. Technically, some of the things that are equations could also be formulas, like the y equals z squared minus z minus 6, if that y stood for something important. In number 2, we're going to use a formula to calculate some things. So we have a cost formula, C equals 2 plus 250 times M. And in number 2, it asks us to plug in a 7 for the M to calculate the cost of a 7-mile cab ride. So we'll go ahead and do that. C equals 2 plus 250 times 7. And when you calculate that out, it comes out to $19.50. In question 3, we're going to do the same thing for m equals 4. So C equals 2 plus 2.50 times 4, and that comes out to $12. This time they do ask us to write a sentence about what that means, and when they say include information about each variable, they mean talk about what we plugged in and talk about what came out as a result. So in this case we plugged in a 4, that was a 4-mile cab ride, and what came out was $12. So a 4-mile cab ride costs $12. Here we're working with the simple interest formula, amount equals principal plus principal times interest rate times time. In number 4, it asks us to think about that formula a little bit. What usually happens with this is you are given a P and an R. So those are actually constants, and then the T and the A are variables. The question then is, which is the input and which is the output? Well, most of the time you're going to plug in a time to determine an amount and not the other way around. So that makes the T, the time, the input, and the A, or the amount in the account, the output. In number 5, forget about that formula for a minute and just think about how you calculate interest. If you start with $2,000 in an account and earn 3% simple interest each year, how much interest do you earn each year? Well, 3%, so that would be 2,000 times 0.03, and that gives us $60 per year. Now in number 6, we're going to substitute those same values into the simple interest formula that we were given. So the amount in the account equals P, the principal, that's the $2,000, plus P, the principal again, times the interest rate, which was 3%, so 0.03, times the time, which we haven't been given, so we'll leave that as a T. So simplifying that, we get the amount in the account equals 2,000 plus 2,000 times 0.03, which is 60, times T. And then the question is, does that make sense based on what we did in number 5? Well, sure it does. That says we're going to take the 2,000 we started with and we're going to add $60 times the number of years, so $60 per year. So then in number 7, we're going to use that formula that we just came up with to fill in this table. So they've already plugged in T equals 0 for us and written down the value of 2,000 in the account. Now we'll plug in T equals 1. That'll give us 2,000 plus 60, so 2,060. And then when we plug in T equals 2, that'll give us 2,000 plus 120, so 2,120. And you can see that we're just adding $60 for each additional year. So then we'll have 2,180, 2,240, 2,300, and 2,360. In 8, what's the value of the account after 2 years? Well, we can see that right here. After 2 years, it has $2,120 in it. In 9, how long does it take for the account to reach a value of $2,240? Well, we can see that in the table also. That takes 4 years. Here we're working with the compound interest formula. A equals P times the quantity 1 plus R all to the Here we're working with the compound interest formula. A equals P times the quantity 1 plus R all to the T power. In 10, we're asked to substitute some values into that formula. So A equals, they've given us a P of 10,000, parentheses 1 plus, they've given us an R value of 0.06, close the parentheses, and then they've given us a T value of 40, so that's the exponent. You can go ahead and calculate that out, and that comes out to about $102,857.18. And then they ask us to write a sentence or two explaining what that tells us. They're really just asking for you to label all of the things that you plugged in. So if we start with a principal of $10,000 and we earn compound interest of 6% a year for 40 years, then after that time we will have $102,857.18. In 11, we're going to use our compound interest formula to write a formula that describes the value of an account that starts with $5,000 and earns 4% compound interest. So A equals, our P is that starting amount of 5,000, parentheses 1 plus, our interest is 4%, so 0.04, to the T. We aren't given a number of years, we want a formula that we can plug different T values into. I'm going to go ahead and simplify that just a little bit and add together the values inside the parentheses. So 5,000 times 1.04 to the T. Now that formula we're going to use in number 12 to complete this table. They recommend using a calculator or spreadsheet, and that's a really good idea. So I'm going to go to my calculator, I'm going to put my amount formula into the y equals screen, and I'm going to create a table. And that's going to let me fill this in quite a bit more quickly. And we can see that this one does not increase by the same amount every time increment. So we start at 0 years with $5,000. After 10 years, we have $7,401.22. After 20, we have $10,955.62, and so on. So in 13, what's the value in this account after 20 years? Well, that's the one I just said, $10,955.62. And then in 14, it says to the nearest year, how long does it take the account to reach a value of 24,000? Well, you can see that at the 40-year mark, it's just a little bit over 24,000. So 40 years. And then it asks whether it hit 24,000 before or after this time. Well, since at the 40-year mark, it's just a tiny bit over 24,000, that means it hit 24,000 just a little bit before that. In 1, if we were to find a formula that relates the distance it takes to stop and the speed the car is traveling, what would be the input and what would be the output? Well, the distance that it takes you to stop is affected by how fast you're going. So that means that the input is the speed and the output is the stopping distance. In 2, we're given the formula for stopping distance based on a speed. So they're using R for speed and D for stopping distance. We're going to go ahead and use this formula, D equals R plus 0.05 R squared, to fill in this table. And a graphing calculator or a spreadsheet would be really helpful. So you can go to your Y equals screen and put in the formula for stopping distance, and then create a table that counts up by fives. At a speed of 5, the stopping distance is 6.25 feet. At a speed of 10, the stopping distance goes up to 15. At a speed of 15, the stopping distance goes up to 26.25, and so on. So in 3, if you're driving at 25 miles per hour, how much distance will it take to stop? In our table, a speed of 25 miles per hour has a stopping distance of 56.25 feet. In 4, how slow would you have to go to decrease that stopping distance by 30? So 56.25 minus 30, we're looking for a stopping distance of 26.25 feet. Looking back at the table, that happens at 15 miles per hour. In 5, a car takes 103 feet to stop in an area where the speed limit was 30 miles per hour. Were they speeding? Well, at 30 miles per hour, it should have only taken them 75 feet to stop. So if it took them way more than that, almost 30 feet more, then yes, they were definitely speeding. In 6, if you're texting and driving at 67 miles per hour, how much stopping distance do you need? Well, first of all, let's figure out what the stopping distance would be for an undistracted driver. With r equals 67, that would be 67 plus 0.05 times 67 squared. And that comes out to 291.5 feet. That's if you're not distracted. If you're texting, you're going to take even longer than that to stop, which is only part of the reason that texting while driving is a terrible idea. In 7, what are some factors that affect stopping distance? Well, there are lots of things that come into that. One is your own natural reaction time, and then there are other things that affect reaction time, like how well you're concentrating and visibility, as well as things that affect how fast the car can stop once you do hit the brakes, like road conditions and weight of the car.